We all think of AI as this sort of digital, cloudy thing. But the reality is, it has a massive physical footprint. It's being built with steel, concrete, and an absolutely staggering amount of electricity. So in this explainer, we're going to pull back the curtain on the huge and often hidden energy grid that big tech is building just to power it all.
So here's what we're going to cover. We'll start with just how much power this AI revolution actually drinks up. Then we'll look at the insane surge in demand that's just around the corner. We're also going to dive into how tech giants are basically turning into their own power companies, how they're dealing with all the red tape, and finally, we'll get to the question that affects all of us. What does this mean for your electricity bill and the power grid we all rely on?
All right, let's jump right in. Where is all this energy going? To really get a handle on AI's incredible thirst for power, you have to look inside its home. And that home is the modern data center.
Now, I want you to get any image of a typical server room out of your head. That's not what we're talking about. We're talking about hyperscale data centers. These are just sprawling, warehouse-sized buildings, absolutely packed to the gills with thousands of super powerful computers, and every single one is designed for the immense workload that AI demands.
Okay, to really wrap your head around the scale here, just think about this. A single one of these facilities, just one, uses enough electricity to power 80,000 American homes. That's basically a small city's worth of power, all of it getting funneled into just one single building. It's wild.
And this is where it gets really interesting. This chart shows something kind of crazy. Only about 40% of all that power is actually running the computers, doing the AI stuff. Another 40%, almost an equal amount, is spent on just one thing, keeping the entire building from literally overheating and melting down. That is a huge energy cost that has absolutely nothing to do with the actual computing.
Okay, so take the power needs of that one data center, and now imagine scaling that up, because that one building is just the beginning. Let's look at how this whole thing just explodes into a massive surge in energy demand for the entire country.
So just in 2023, data centers in the US used 176 terawatt-hours of electricity. That might just sound like a big number, but it was already 4.4% of the entire country's power usage. And here's the kicker. That was before this whole generative AI explosion really took off.
Because what's coming next is, frankly, astounding. A recent Department of Energy study is projecting that by 2028, and that's just a few years away, the annual demand could rocket up to 580 terawatt-hours. We're talking about more than tripling the demand in just 5 years. That's an incredible jump.
Let's really put that into perspective. We are talking about going from data centers using, let's say, roughly 5% of all electricity in the United States to potentially over 12%. Just think about that. No other industry has ever added that much new demand to the power grid that fast. It's completely unprecedented. So with that kind of insane demand, you can't just go find a big enough wall socket to plug into. The public grid we all use, it just wasn't designed for this kind of load. So what are the biggest tech companies doing? Something pretty radical. They're starting to build their own private energy infrastructure.
So they really have three main playbooks here. First, there's the old school way. Just buy power from the local utility company. Second, they can sign something called a power purchase agreement, a PPA, which basically means they contract to buy all the electricity from one specific power plant. And then there's the third, most radical option, self-supply. That's where they build and run their very own power plants, right there on site.
And you can see here, they are going after every single option you can imagine. I mean, Microsoft is backing the restart of a nuclear unit at 3 Mile Island of all places. Meta is building enormous natural gas plants. Google's putting money into next-gen geothermal. And look at this last one, a proposal for an 11-gigawatt nuclear plant in Texas. That is enough electricity for millions of homes. This is the key point. They're not just buying power anymore. They are becoming power companies.
Yeah, this quote really nails the new strategy. The key phrase here is balanced portfolio. It's not about just picking one source, like solar or wind. It's about building their own private mixed energy portfolio. They're combining renewables with stuff that's always on, like nuclear or natural gas, to create their own system, a system that's totally independent of, and maybe even more reliable than, the public grid we all share. Okay, but it's not that simple, right? You can't just wake up one day and decide to build a nuclear reactor or lay a new gas pipeline. All of this ambition is slamming right into an incredibly complex maze of rules, federal, state, and local regulations that control every single new energy project in the country.
And getting these projects built is a true gauntlet. It's not just one approval. You need a green light from federal agencies like FERC, which manages the grid, or the NRC for anything nuclear. Then you have to get state and local governments to sign off. And on top of all that, there's a whole list of environmental permits for clean air, clean water, the whole thing. It's a process that can easily take years, sometimes a decade.
Now, this massive challenge has definitely not gone unnoticed in Washington. The federal government sees that all this red tape is a huge bottleneck for the entire AI industry. And that's exactly why we're seeing this flurry of activity. A new AI action plan, executive orders, new laws being proposed, all of it is aimed at one single goal: clearing the regulatory path so this critical energy infrastructure can get built and get built faster.
Okay, so let's bring this all back home. We've got this huge new demand for electricity and a whole new private power system being built to meet it. So what's the bottom line? How does all of this actually affect you, your power bill, and the grid that we all share?
This is probably the #1 question on everyone's mind, right? Is this AI boom going to make my electricity bill shoot up? Well, the answer, as it turns out, is it's complicated. It really, really depends on where you happen to live.
Just look at these two totally opposite situations. In the Mid-Atlantic's PJM region, there was this big surge in data centers, which forced them to build expensive new grid infrastructure. The result? People's electricity rates went up, in some cases by as much as 20%. But then, you look at a place like North Dakota. They had extra power just sitting there. So when the data centers moved in, the utility could spread its costs over more customers, and guess what? Rates actually went down.
So you see, it all boils down to one single factor. Does the local grid have enough power to spare? If a region has extra capacity, a new data center can actually be a good thing for everybody's bills. But if the grid is already stretched thin, their demand forces expensive new construction projects. And you can bet those costs often get passed right along to every other person in the area.
And this right here, this gets to the real heart of the issue, the biggest idea of all. For 100 years, we've treated electricity as a public good, right? A shared resource regulated by the government for everyone's benefit. But what big tech is building right now, these private nuclear plants, these off-grid data centers, these parallel energy networks, this is something fundamentally different. It's a huge shift away from that public model. And it makes you wonder, what happens when our most critical resource isn't really public anymore?
And maybe the most remarkable, or unsettling part of this whole story is that this massive transformation, I mean, we're talking about a historic re-engineering of our entire country's energy system, is all happening incredibly fast and almost completely under the radar. There's no big, widespread public debate about what this all means.
And so that leaves us with this really critical question for the future. As AI's energy needs create this new parallel power system, who gets to decide how our national grid, the one we all depend on, is actually used? Who's in control? That's a debate we are only just beginning to have, and the answer is going to define the future of energy for every single one of us.